Hello again. This is Lab 5, Build Your DB Server and Interact with your DB using an app. I'm Richard Golson, and let's move into Task 3, Create an Amazon RDS DB instance. Now recall in the last two tasks, we were preparing for this. So we created a security group for the RDS DB instance, and then we created a DB security group. Let's take a look at the details of this. So you can see that when we deploy the RDS instance, we're going to configure and launch a multi-AZ RDS deployment of a MySQL database instance. So Amazon RDS multi-AZ deployments provide enhanced availability and durability for our database or DB instances. This makes them a great fit for production database workloads. When we provision a multi-AZ DB instance, RDS will automatically create a primary DB instance here and asynchronously replicates the data to a standby instance in a different availability zone we can see over here. Both databases, following best practices, will be launched in private subnets, which we learned in our VPC module provides additional layer of security, as these do not have ingress rules that allow traffic to flow into those private subnets from outside of our VPC, from the internet. So they're going to be protected in that way. We'll see later on how we connect these DB instances to the web server. All right, let's go ahead and progress. We can see here that we'll be clicking on the Create Database. So I have the Create Database button here in the RDS dashboard, which I've already clicked, and we'll take a look. We're going to walk through this because I want to show you the default settings, and then we'll walk through the settings that we're going to deploy. So here you can see that the default is for a standard create. You could use an easy create, which would give us best practice configurations, which is great when you go into production. You know what you're looking to do. In this case, we want to do this from scratch, so we're going to do the standard create. So here's our MySQL. Note that Aurora is considered one of the RDS databases. This is MySQL compatible. We're not going to be using it. We don't need it. So we'll select the MySQL as indicated over here. And then what we're going to do is come down here and select the dev test template. Before I do that, I want to point to you that we're using the MySQL Community Edition. And if there are any known issues or limitations, we'll get a message here that displays a link that would take us back to the documentation. We could take a look at that. We also could select a different engine version. You can see it doesn't select the most current engine version, but it also doesn't select the older engines. But if we need those for backward compatibility, we could. So we'll leave that alone. So we're not touching that. However, under templates, what we want to do is change the setting from production, which is going to deploy automatically high availability. You'll notice that it actually points to the multi-AZ DB cluster as the default. We're going to switch to dev test. Notice that that now selects single DB instance by default, because if you're just doing development testing, we don't want to pay the additional cost to run multi-AZ if we don't need it. So we are going to change that, however. So if we take a look back over in here, we can see that we will be selecting the multi-AZ DB instance because we want to see what that looks like. This creates the primary DB instance and then the standby DB instance in that second availability zone. This gives us the high availability and the data redundancy. All right. One thing to note that when we deploy that, this standby DB instance will not support connections for read workloads. So it's there simply for providing more resilience. If our primary fails, then traffic is switched over by the RDS service to the standby instance in the second availability zone. Scrolling down here into the settings, we're going to go ahead and configure these now. So I'll go ahead and just copy and paste. We want a DB identifier. This is going to be the name of the database instance, not the database that's on the instance, but the name of the instance itself. And then the master username. So this will allow users to interact with the database that resides on that DB instance. So notice that we switched to main, and then the password. I'll go ahead and populate. It's the same value, so I'll go ahead and populate that in both fields. Note some of the options here. We could manage the master credentials in the AWS Secrets Manager service, which is really great because this would then allow us to generate a password and then manage its lifecycle, which means we could get automatic password rotation and updating of the password on our DB instance. So it's a great way of providing additional layers of security and best practices. We could just auto-generate a password here, but note that we use the passwords that were provided. Now, coming down here for the instance class, if we recall, our DB instance is a special AWS managed EC2 instance. And there are some specific instance classes, what they call instance configurations that we could, or classes here, we can see this, that we can select. They're not going to be all the same classes or instance types that we would see for EC2. So we're going to select a burstable class, right? So we'll select the burstable class. This can help reduce costs, but it might not be suitable for production purposes, but it'll be perfectly fine for what we're going to do, which is dev test. And then take a look here. We're getting the db.t3 micro. Let's make sure that matches here. So we'll go ahead and leave that alone. If you needed to change it, you can click and select from the list. We'll leave that alone. And then what we're going to do is take a look at storage. Now, here's another area where we will modify the existing configuration. Note that it says here general purpose, and we could just leave this. When we select this, you'll notice there isn't just a general purpose setting. They provide general purpose SSD GP3 or GP2. Note the differences in the way that general purpose or GPT-2 and GP3 work. With GP2, the actual performance, the IOPS that we get, input output per second, we get a baseline performance, and that's determined by the size of the volume. So if we reduce the size of the volume, our baseline performance would decrease. We are reducing the size of the volume. And what's great about leaving this at the GP3 setting is it means that it will the IOPS that we get, the performance, will not change based upon the size of the storage. So if we leave this alone, we're not going to be decreasing our performance when we reduce the allocated storage to only 20 gigabytes, which again is going to be plenty for this dev test, which has a very small database. Now, let's take a look at some other settings down here. We need to get into the connectivity setting here. So we'll be selecting, as we have been throughout the lab VPC. That is our VPC. So when we come down here and take a look under connectivity, note that we'll ignore this, the compute resource connectivity, and we'll leave the network type set at IPv4 and then change the VPC to lab VPC. So I need to look for lab VPC in my list, which is right here. It has the 4 subnets and 2 availability zones. And then we take a look at the DB subnet group and notice that it already selected the DB subnet group that we configured in the previous task, which is great. And it's because we only have the one DB subnet group. So it selects that for us. It didn't allow us to actually create one at this time. That's why we had to create that in advance. Let's look at the next setting. So we took care of this, the DB subnet setting, but what we want to do is get into that DB security group that we created. So when we come down here and take a look at the the VPC security group that we'll be using, it says choose existing. That's what we want. But notice the existing is selected by the default security group, which is not what we need because we created one for this. So we're going to select the DB security group. Now, if you recall, the DB security group, we take a look at it over here, is allowing traffic on port 3306 from the web security group. The web security group is the one that is used with our EC2 instance. And we can see here it's using the web security group. So this is going to allow traffic on port 3306 from this web server 1, which is hosting our application. So this is just the right selection for us. So we'll come back down here. We've selected that. Now notice that the default security group is still selected. We don't know what traffic is flowing across that, but we're going to deselect the default. There we go. So we only have the DB security group selected. Now we need to get to the monitoring section where we will expand additional configuration. So let's scroll down, and here's monitoring. Now, one of the things that's a little bit confusing is note that even I was sort of following what it said here. We're not going to expand additional configuration. Before we expand additional configuration, we're going to uncheck enable enhanced monitoring. So here's what we're going to do. We're going to uncheck that. When you use enhanced monitoring, these are useful when you want to see how the different processes or threads are using the CPU. Typically, we want the enhanced monitoring when we're monitoring the system because we're seeing some slow behavior. We're seeing latency in our database. So what we really want to see is where is this latency occurring? So using the enhanced monitoring, which adds additional load and cost, this would help us troubleshoot. We don't need that. So we're going to uncheck that. We can always add that later. Now we can expand the additional configuration, which is mentioned right here. So we'll expand that. Just a little typo in their instructions. We're going to set the additional database name. Now, this is the actual database that it will be stored, created and stored, or created and hosted on the DB instance. So note the name is actually lab. It's different than what we saw previously when we configured the name of the instance. So this can be a point of confusion, which is why I pointed out. So when we come back up here, you'll see the DB instance identifier. Its ID is labdb, but the database itself has a different name. The initial database name is just lab. We're going to uncheck two settings that normally you would leave. It's recommended that you leave them checked so that they can perform the automatic backups and enable the encryption. But that's going to slow down the deployment. So we don't need those in our test bed here. So what we'll need to do is scroll down and find those settings. So here's backup. So before we uncheck it, note that the backup retention period, it creates the point in time snapshot of the database and then stores that, retains that snapshot for 7 days. And you can actually modify that. So you can keep additional snapshots so you could roll back. That gets expensive because every snapshot that's created and stored, we're paying storage fees on that because those are stored in an AWS managed S3 bucket, and we get storage fees on that. So we're going to uncheck enable automated backups. We're also going to uncheck enable encryption. Before we do that, do note that it uses a KMS key, an AWS KMS key, and this would encrypt our volume. Again, this is going to slow things down. So the two things we unchecked, enable automated backups and enable encryption. And then what I'll do is I'll come down here and just take a look at the last few items. So note that we have things like log exports. There's a maintenance option, a maintenance window, and then deletion protection. This is the cost per instance. So this is a per instance cost. So note that it breaks it down. The DB instance itself is $24.82. Our storage is $460. If I went back up and modified that setting and put it back on the 200, I have to find that again. That won't affect anything else that it's on here. Let's take a look at the price here. We should have looked at that sooner. You notice the price went way up, right? Our storage is $46. So this is drastically reducing the cost. So we're going to go back up again. This is for a lab, and having such a large volume, we don't need room for growth. When you create an RDS instance, you don't need to create it with room for growth because we can add room. We just need to be monitoring to make sure we don't run out of space and then affect our production. So notice the price dropped dramatically, right? So we'll go ahead and create our database now. Now it's going to take about 4 minutes for that database to be available. Notice that my browser wants to save this information. So I'm just going to click out of that, make it disappear. And then notice that I can see my DB instance is displayed on here. It's telling me that it's creating it. It's also allowing me to see the database credentials. So if I want to check that now, I'll go and click on that link. You can see that this is that master username main and the master password, which is lab password. And I can actually copy that. What I don't want to do is close this. It makes it easier to get access. Later on, we will see it'll add a little bit more information. So I'll go ahead and close that just by clicking that and leave that open. Right now, it's telling me it's creating the database. And we can see that it's in create, the status is creating, and I'll click the link here to open an additional tab so I can keep an eye on things here. I'm going to close this panel up. And then what I'll do is periodically refresh this. So what I'm waiting to get is my endpoint. I'm also waiting to see that the status goes from creating to ready. Okay. So I can use this button to make that happen. We're going to go ahead and pause the video. When it's ready, we'll take a look at that. All right, welcome back. Note that we can now see the endpoint, and we'll be using that endpoint when we're connecting our RDS instance to our EC2 instance. We notice that the DB instance is in a modifying state, so it's not quite ready. So what we can do is go ahead and stop this video, go to our next lab or our next task, which is interacting with the database to connect the DB instance to the RDS instance. And at that time, we can go ahead and proceed. And then once this status changes to ready, it'll actually function correctly. We can be prepared to then finish up the lab. All right, we'll see you then.